What's up, guys? Chris with CNC for Newbies and Croft CNC here. Um, Couple things. One, for those of you that have been asking, my medical prognosis has finally been understood. Um, for some odd reason, right before all this stuff happened, I had a really rough night one night, um, and I ended up passing out, and I hit the back of my head. And me and my wife had forgotten about it. Well, it turns out that me hitting the back of my head caused uh, a lot of neurological damage. I actually have uh, some brain damage. Uh, they're listing it as a traumatic brain injury, and because of that, certain pulses from the brain, certain electric pulses from the brain, are not going where they should, and certain pulses that the brain is looking for are not being received. So there's really nothing I can do for it. This is my life, and um, that's what we're going to move forward with. So thought that was pretty cool. I shouldn't say pretty cool, but it's pretty cool that they can uh, medically be able to tell us this type of stuff. Um, and the journey that I've been on with it has been really cool because I've gotten to see some of the CNC robots and some of the parts that they make with CNCs being used on me to diagnose me. It's pretty cool. It kind of came full circle because as they're doing stuff, they're trying to tell me about procedures, and I'm looking at their robotic arm like, oh, that servo is doing this. Oh, I wonder what that control system looks like. um, but today's adventure, we got the tool changer all done. I am doing a little bit of cleanup and housekeeping to it. The cleanup is going to be bulkhead fittings for the pneumatics. I added another airline, and that's a straight through airline off of the main regulator. And that will allow me to put a cleanup nozzle, like a regular air nozzle. And I'm going to 3D print a hook that goes on the front so that I can set my air nozzle. And you'll be able to basically clean off your table from the air supply that runs the tool changer. But from that point, I wanted to put together the closed loop control system. We're looking at a couple different closed loop control systems for the new 5x10 Pro machine. And with that, we wanted to have a professional closed loop system. And I'm playing around with some of my motors and drivers and stuff. And hey, what's up? Good morning, sir. Uh, I honestly, uh, I honestly don't recognize Karachi Killer. So I apologize if I'm supposed to know the name, uh, like your real life name. Um, I apologize. Sometimes I meet people where I don't associate your name with your online. Um, but in any event, we're doing some. Oh, is that Mark? I We've got a YouTube subscriber called Karachi Killer, and I believe that that's Mark. And Mark, actually, Mark, you and I need to talk because turns out that I got a TBI. So, in any event, um, we are doing some closed loop stuff here, and people think that these control boxes are really complex and nobody understands what's going on. And basically, you have a microcontroller, which would be, in our cases, for XCarve, like Bob CNC, Shapeoko. Well, no, Shapeoko, I think they use a Duet. But anyways, like XCarve uses an Arduino Uno. Millwright uses an Arduino Mega. Um, CNC for Newbies uses a either a Demon controller, which uses an Arduino Uno, or we use a UC CNC controller, which uses a UC 100 or 400 control microcontroller. All of that stuff feeds into what are called breakout boards. And breakout boards basically just take the electrical connection and communication connection to the computer and separates everything out. So the breakout board is very simple. You guys know what the controllers are. This is a simple breakout board. Okay. On top of the simple breakout board, like the Arduino people don't call them breakout boards, they call them shields. All of it is the same. Okay. A shield is just a breakout board. A breakout board is, for lack of a better comparison, a shield. Okay. It's basically just taking all of the input outputs of the controller, of the microcontroller, and putting it out into individual strands for power communication. Okay. Then outside of that, you have drivers. Those are either stepper or servo drivers, or hybrid drivers. And with that, you have a power supply. Power supplies are pretty easy. They provide power to the drivers. Sometimes they provide power to the overall system. Okay. In my UC300 controller box, I have a 5-volt power supply, a 12-volt power supply, and a 24-volt power supply, and a 36-volt power supply. The reason being, I have a bunch of different power needs for that, because I can use up to 5 breakout boards. Okay. So the actual composition of a open loop or closed loop controller is pretty much the same overall. All right. The big difference in closed loop versus open loop is going to be the driver selection. And open loop, the best way to talk about open loop systems is it's a flying blind system. Okay. The computer tells the machine, move 1 inch. Sometimes the machine moves 1 inch. Sometimes only one motor moves 1 inch. Sometimes nothing happens, or sometimes it doesn't move the full inch. The computer does not know that. And so when it sends the next pulses out, it's assuming that the machine moved the correct position. Okay. When it assumes that it moved the correct position, it moves from where the tool is to the next position, and that may not be the right position. So there's a lack of feedback to the computer so that it knows where the actual system is at. There are remedies for that. And that's where we transition into the hybrid or the full closed loop system. And the hybrid system is just that. It's part open loop, part closed loop. And what I mean by that is the hybrid system, which this is a hybrid system at the moment. Okay. The the hybrid system goes from the computer to the control box. The control box disseminates all the information to the machine, right? But the motors, let me see here. Let me get a motor. The motors, instead of just having that 4-wire plug right here, they have an encoder plug also. And that encoder plug basically is attached to some type of linear or quadratic or segmented optical encoder. Some type of segmentation happens, and there are feedbacks that go back to the driver. Okay, so it's looking for certain pulses out of that encoder to then feed back to the driver. So when it feeds back to the driver, the driver says, I told you to move 1 inch. As far as our calibrations are set, we move 1.25 inches, move back. Or you moved 7/8 of an inch, move 1/8 of an inch more. This is very simplistic, guys. Don't take this as gospel. This is a very lay term setup. I don't know enough of each individual component to speak as an expert in the field, and I learn new stuff all the time. So I try to do a lot of research on this, but everything's changing all the time. So, anyways, so the encoder monitors where the motor is at, and it feeds back to the driver. And the driver is the endpoint for that encoder. That's what makes it a hybrid system. Is the computer itself is still flying blind, but the driver, the control box, is actually taking care of the feedback. Okay. At the moment, I don't have my plasma cutter up and running, but my plasma cutter is a full closed loop system. So what that means is it's just like the hybrid system where I tell it to move 1 inch, it monitors to make sure that it does move 1 inch. Okay. The difference between my full closed loop and my hybrid system is my full closed loop then has feedback all the way to the computer program that says, I told you to move 1 inch. And the motor says, yeah, I did move 1 inch. Here you go. And it feeds all the way back to the system, and the system is good. Okay. So that's kind of the differences of where things are at. You can go through and you can have hybrid systems. You can have full closed loop systems. Industrial machines, a lot of times, will have a full closed loop system that feeds back, and the reason being, they need that. They absolutely need that. Hobby machines typically will have an open loop system because building a closed loop system is a little more costly, a little more complex, and there's more settings um, than your regular open loop system. You guys are well aware. Phil Johnson put out the DIY Demon controller. Um, right now, I built an open loop system with Demon controller. I upgraded the drivers a little bit, but my basic Demon controller cost me about $200 to build. Okay, my upgraded Demon controller cost me about $350 to build, because I upgraded drivers. So I have digital drivers that they have better chips, better setups. Um, you know, my closed loop system or my hybrid system is running me about $800. Okay. My full closed loop system that setup is much different. It cost me about $2,000 to make. Not sure why it froze. Huh. Anyways, not very economically sound for hobby people. Um, the the hobbyist typically is looking to get into it at an inexpensive rate. But if you need tolerances and everything, the full closed loop system is the best way to go because you have full feedback. Um, next on the list with that is the different type of encoders. Okay, for this setup, the encoder is on the motor. Okay, this is a simple. I have a simple encoder on the back of the motor, and it feeds back. Um, that's good if you want to monitor how far the motor moves. Okay. Um, Sometimes that's simple enough, especially with like a screw driven machine. Um, for this system that I'm putting together today, this is an entry level hybrid system. I just want to know where the motor is at. Did it skip steps? Did it go too far? Did it go too short? And I can work on calibration. Now, I don't have one with me. I don't have one with me because I wasn't planning to go this far in detail with it. But on my rack and pinion machines, I use anything over 4 foot. I use rack and pinion for the long axes. If it's at 4 foot, sometimes I'll use a ball screw. Sometimes I'll use a rack. It depends. CNC for Newbies uses rack on X and Y. They use a ball screw or a lead screw on Z for a big one. Okay. With the rack, you have backlash built into the rack system. So an encoder can read the motor, but it may not be in the correct position setting that up. So like on my CNC quilting machines that I build, I use what's called a linear encoder, a slide encoder, or a glass encoder, or a tape encoder. And what that is that's actually a linear distance encoder. It actually reads how far the gantry or the axis actually moves by having you have like the motor here. Okay. You would have the encoder would say be hanging off of here, and it would roll. It would have a roller or something of that nature that engages, say, right here. So as this whole gantry moves, it's getting a linear reading of where it's moving along this linear measurement. Okay. That is probably, in my personal opinion, it's probably the best setup for rack and pinion machines. But it's also the most expensive to build because you have to have different bracketry, you have to have different encoders, you have to have extra space because like on my quilting machines, my encoder actually hangs 4 inches forward or aft of the uh, gantry. Okay, so I need an extra 4 inches in the front or in the back of that gantry movement to align that encoder. Okay, it's harder to find places to interact with that encoder in terms of mounting it on the plate or the motor mount or anything like that. So you may have a linear encoder that hangs off here and it rolls down the length, and it's going to say, hey, I told the motor to move 1 inch. Oh, I only moved 0.987. Okay, either throw a fault or fix it. And all of that stuff is calibration stuff that you can actually get in, and you can talk about this stuff with the computer and say, I want you to be this close. The downsides, because right now we've talked about it, and the upsides are phenomenal about open loop or closed loop systems, right? The downsides, it can be much harder to calibrate. It can be much more finicky. If it doesn't meet one criteria, it can shut down the whole system quickly, um, based on how you have the feedback loop set up, uh, in nanoseconds and everything like that. Um, so sometimes you may have it set up where the encoder faults out. It doesn't move 1 inch when you tell it to. Sometimes those closed loop systems are set up to correct that, if they can pulse it before the next move is initiated. Sometimes they're set up that, hey, I faulted out completely, stop and alarm the system. So it'll actually stop the system for you. It's kind of crazy when you think about it, that it's that quick, that precise, and that awesome. But in the same token, that can be really bad if you have one different deviation wrong in the encoder and the motor pulse. Um, it may fault out all the time on you, and all it is maybe a nanosecond delay, and you could save yourself a bunch of heartache. Um, there's there's a ton of stuff to be said about the guys who know this stuff in depth, and guys who interact with the closed loop systems, uh, on a professional level. They uh, they still are are in my eyes magicians, because I don't understand a lot of the stuff. Um, I have a friend that brings over an oscilloscope and sets everything up, um, and he'll get in there and he'll be like, okay, this pulse is doing this. It's not quite a square wave, so let's taper it off here. Let's pick it up there, and he knows that stuff, and I'm just amazed whenever he does that, because I haven't gone that far into it. I set it up so that it runs, and I get the feedback that I want, and that's good enough. He, on the other hand, is like, no, this is what they were made to do. We're going to make them the Ferrari of what they're supposed to do. I'm like, okay, you do you, man. um, but for those of you that don't quite understand how open loop versus hybrid versus closed loop works, that's a little bit of an insight. And the best part about that is closed loop systems can correct themselves, and they can fault the system before you ruin a part. Okay. So I've got some guys right now that are playing around with their velocities and accelerations, and they're missing steps, and they don't understand why. Um, Part of that is poor calibration. You didn't calibrate right. You didn't set up your speeds and velocities right. Um, you know there's backlash in the system that you've got to take up. There's a lot of in-depth stuff that isn't necessarily hobbyist grade stuff, um, that you can do with some of these systems. And um, when you start looking at that, you start going, oh, okay, this is something that I need to do here, and I need to do this, and you'll get the system running really well, right? But with a hybrid or a closed loop system, it can stop the system, or it can correct the system if you're losing a step or you're missing a step. Um, and that helps save a lot of setup, or a lot of scrap wood, a lot of burn pile wood in our case, because the machine should know where it's at all times. And when it knows where it's at all times, it also is able to go back and say, "Hey, that's not right. Stop before you ruin something." Now, with an automatic tool changer, you can fly blind. You can use an open loop system. I personally would not. I think that that's dumb to do that to a point. And the reason why I feel that it's dumb is, if for some reason that backlash compensation isn't set, that calibration number is not set, and you have a compounding value of tolerances, you miss a buildup of missed partial steps to create a full step miss. You now you now have something where you can crash the tool changer, you can crash the tool holder, you can break the bits. If you miss the target for probing, you can ruin your touch probe. You can there are a lot of things that can happen when you do this stuff flying blind. And the machine assumes that, or the computer assumes that the machine is where it wants it to be, and sometimes it's not. Okay, so just realize that there are a lot of added advantages, but the biggest con to it is setup. The second biggest con to it is cost, is initial cost. Um, do you recuperate that cost over time? That's a loaded question, because nobody really knows. It's all about how much would you have actually made without that closed loop system, uh, versus how much you threw away. I know guys that right now they're throwing stuff away because they're not calibrated correctly. I ran my 4896. I ran that for shit, what, 3.5 years open loop, and I never had an issue, you know. But I always did maintenance. I always did calibration. Once a month I'm doing calibrations, backlash compensations, and everything like that. Any of my upgrades, I'm doing the same thing. I upgrade it, I calibrate it, I do my backlash compensations. Um, these are all things that, as you progress in the hobby, that you should understand and you should start doing. Um, that's my personal opinion. Some may differ. But with that being said, I've got all these wires to start routing. I've got airlines to route. I've got VFD wires to route. I've got uh, switch wires and relay wires to route. So I'm going to get to soldering, extending, and maneuvering. And let's go over some of the stuff out here. Um, we got lost connection, but I'm okay now. Karachi Killer Mark is using the Stock X controller because he's poor. Man, Mark, there's something to be said about the adversity of men and women that want to get into this hobby. The fact that we can have these machines in our garage doing this stuff is what makes it great. Your X controller is a good controller. Is it the greatest controller? No. It might be the greatest controller for you. You know what you're after. You know what you're doing. Um, and you know what your skill level is. So it might be what's best for you, right? So there's nothing wrong with your X controller, and it's not because you're poor, um, because you can actually take the parts, uh, the chipsets and stuff, and you can pull those off the X controller, and you can build your own controller boards. Um, you could also turn around and just build a Demon controller. And the difference between the X controller and the Demon controller, at a financial cost, is if something goes wrong with the Demon controller, you can replace individual components. If you have extra money, you can upgrade individual drivers as you have the money. You can nickel and dime your way up to a great controller, because everything is its own part. It's not a part of a whole unit. Um, and I love the fact that Phil Johnson took the time to not only build a Demon controller, but he also gave you guys the information for free. Okay. If he was like, hey, I like building this stuff, so I build it. But if you want to learn how to build it, here's how I did it. And Phil, huge shout out to you, man. Great job on the Demon controller. Um, I run a Demon controller on all my Arduino systems. And I run Demon controllers on my lasers and stuff like that. My Alex makers, I take their little $25 uh pop palo Palulo whatever drivers, the A4 drivers. I take those off. I put a Demon controller on there because I like the product, because of its ability to upgrade over time, its ability to maintain as needed and not have to buy a whole new controller when something fails. Um, so uh, that addresses things like the X controller, things like the Millwright controller. The Millwright controller is basically a Demon controller with a Mega. The downside to it is a lot of the stuff from uh, a lot of the stuff from that board is not able to be utilized because the UGS or PIC sender or any of the Arduino senders, they're really dumb right now. But I'm hoping that gets taken care of with the I think it's called IO sender and the new 32-bit systems that are coming out. Um, I like the look of those for the Arduino systems, and I hope that really brings us up in the hobby level. We have a Facebook user that says they're the king of the scrapwood pile. I think everybody here is the king and queen of the scrapwood pile at some point in their jaunt through CNC. That's one of the things that makes this great is you can be. I tell all of my students, and people can attest to this. I'm not shy about it. Your first day, your first week, you're going to be so excited about your machine running. You're like, I got this, I'm doing this. And then a month into it, you're going to be cussing at me, and you're going to be willing to sell your machine because it's not running right, and I don't know why this machine is so stupid in doing this. And it's like, it's not the machine, it's you. Just understand that it's you. You did it. Stop bitching and figure out why. Why did it happen? What is it that's doing this? Um, and then a year into it, you're going to be teaching people how to do it themselves. And I love that aspect of it. It just shows the growth, the understanding of something that was so foreign to you in the beginning, and then a year later, like, you do it in your sleep. And you guys that are doing it in your sleep, you're doing amazing things. There's a lot of really great laser work being done. Taylor and the guys over at Patriot Nation are making some great files. The Taylor is actually showing how he cuts his files, and he's showing you how he utilizes his machine to make his 3D flags and stuff. You guys, Mike Marshall, I think has some really good setups on how to make V-carve signs and stuff like that on his YouTube. I mean, we're living in a day and age where you can teach yourself anything just by some research on YouTube and Google. So take it for what it's worth, man. Let's see. King of Scrapwood, we got Mark exactly. Mark hasn't had any issues with his X-Carve. X-Carve can be hit or miss. If you stay up with maintenance and you maintain the belts and you maintain the V-wheels, the tensions, and everything like that, you're going to have a great running machine. But the problem is most people don't know how to maintain that stuff, and they don't know that they're supposed to maintain it on a regular basis. So the machine gets out of whack. And instead of somebody saying, hey, it's my fault, they say, this is a hunk of shit machine. It's not a hunk of shit machine. Are there better machines out there? I personally would say absolutely. CNC for Newbies is a better machine. But there are people out there that are starting out that call me up and bitch at me about CNC for Newbies machines because why do you have newbies in the title and it's not really a newbie friendly machine? Well, because it's made to be the best machine that we could manufacture for our people. You know, we're trying to give the best bang for the buck. Are there better machines than CNC for Newbies? Absolutely. Not in the same price range. So what do you have more of? Do you have more time or money? If you have more money, go out and buy a closed loop servo system, 4x8, 5x10 machine, automatic tool changer. All you have to do is plug and play and learn the software. But you still got to learn the software. So you've got to put work into this hobby. It's not the end all be all when you buy a machine. It's not, I put my machine together or my machine was delivered and I push a button and I turn out signs. It's not that simple, guys. It never will be. You know, the smartest people are the ones who tell you they're the dumbest because they understand. I know a little bit about a little bit, and there are many others that are much smarter and much better than I am. And that's the mentality to have when you do this stuff. Let's see. We aren't as smart as you. Bullshit. You guys are smarter than me. The only reason why it seems like I might somehow be smarter is because I play around with this shit and I go live all the time. Other than that, I play around with stuff. I break stuff. That's what I do. That's how I make my money is I break stuff. You know, I wish I could be like you guys and rolling in the money, doing signs and stuff like that. I got to be honest, I haven't turned out a sign in the past 3 months. I'm coming up on almost a year here in Florida. The cool part about it is my clientele is much more affluent here. So in Miami, something that I would sell for $100 in Pennsylvania, like I have to sell it for $500 here. People think that I'm trying to cheapskate them. I'm not using the best materials. I'm not this, that, or the other. For some reason, they equate the money aspect to a great product. But hey, if you want to pay $500 for something that I generally cut for $100, by all means, send it over. But outside of that, that's kind of where it's at. Is you guys have it. You guys, I learned from you guys. I learned from the Bobs. I learned from Phil. I learned from Bjorn. I learned from Billy. I learned from Jeff. I learn from Taylor. I learn everything you guys do. I go through. I look at all the posts once I get a chance of all the groups that I'm a part of, and I'm like, hey, I really like that fixture. Save that picture, and I'll refer back to it. I'm gonna do this. Do I have any fixture setups for that, or oh, I want to do this type of design. Fusion 360 does this. Did anybody else replicate that in Vectric? Adaptive tooling. You can do adaptive tooling in Vectric. You just have to put your own tooling paths in. That's the hard part. Okay. IO Sender and Gerbil Hall 32-bit. You guys that are wondering about that in the groups, a gentleman by the name of Bjorn is really big on the 32-bit system. He gives me a lot of information, and he always kind of guides me through whenever I need stuff for the 32-bit system understanding. You guys reach out to him and ask him questions. I know he's busy a lot of times, so he'll get back to you whenever he can. But he's for the Gerbil Hall and the 32-bit systems, he's a plethora of information. So far, he's the only one that I really know that's like, yes, I'm doing this system. So take that for what it is. Mark says the machines are smart, the users are not educated. Absolutely. Absolutely. I will 100% agree with that. I have days where I'm off and maybe I thought that I homed the machine and I didn't. And whenever I go back, I realize my mistake. And the whole time I'm sitting there going, this damn machine is not doing what I want it to do. Da, 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 da. That's the wrong way to look at it. You have to stop, take a breath, and you have to go, what did I change? What am I not doing? Okay. And that's basically it. That's the live for today. So with that being said, I got to pick up my Dogo Argentino. I got to teach like 5 classes today, and I got to work on this this closed loop system or this hybrid system. And then after the hybrid, I'll implement the closed loop, and I'll show you guys how we tie it all back into the computer. All right. Any questions, comments, concerns, pop them down below. I'll try and get to you. If you're on the schedule for teaching, I'll be active here in a little bit, and I'll holler at you. Peace, guys.